Welcome to this video. We're going to be focusing on arithmetic sequences. This is aligned with mathematical analysis and approaches, standard 1.2. So when a sequence grows by a constant adding or subtracting between the terms, this is known as an arithmetic sequence. Take a look at these two examples. In this first one, 7, 5, 3, 1, we're subtracting by 2 each time. In this next one, 1/2, 1, 3/2, 2, we're adding by a fraction 1/2 each time. So we're adding or subtracting some constant between each of these terms. So the common difference we denote with a d. So in this case, d would be -2 and d would be 1/2. And each of the terms of the sequence is written u1, u2, u3, u4, so on and so on, all the way to un, where n is the last term. So we can derive the formula for the general term in the following way. u1 is our first term. The second term, u2, is going to be that first term plus d. The third term is going to be u2 plus d, but remember u2 is just u1 plus d. So that 2d's become 2d. So we have u3 equals u1 plus 2 times d. And then again, the process continues and we get u1 plus 3 times d. And notice whatever this number is, it's always one less than n. So that's why you get this formula here. un equals the first term plus 1 less than n times our common difference d, where n is a natural number. So all of the terms of our sequence are whole numbers. You're never going to see the 1/2 term. You're always going to see the first term and the second term, whole positive numbers. The fourth term of an arithmetic sequence is 18, and the common difference is -5. Determine the first term and the nth term. So let's write out what we know. The fourth term is going to be 18, and the common difference is -5. We're looking for the first term and the nth term, or the general formula. So we know that, let me just write out the general formula. un equals u1 plus n minus 1 times d. So I know u4 equals 18, so I can plug in some things here. u4 is going to equal u1, which I don't know, plus n, I do know this is the fourth term, minus 1 times d is -5. Now, this is actually going to equal 18 because I know u4 equals 18. So this becomes u1 plus 4 minus 1 is 3. 3 times -5 is -15. And then I just need to add 15 on both sides. I get u1 equals 33. So that's the first term. To find the nth term, I just got to write out the formula. un is going to equal u1, 33, plus n minus 1 times d, which is -5. And we can simplify this a little bit more. un equals -5n, because 5 times -5 times n, and then -5 times -1 is +5 plus 33 gives you 38. So this is the nth term. In this example, we're going to find the number of terms in the following arithmetic sequence. So notice that it's not infinite, it stops at 83, and same thing for the second example. So we just need to figure out how many terms there are. In other words, we need to figure out what is n. So I've already got enough information here. I know the first term is going to be 20, and I know the last term is going to be 83. I also know that it's jumping by 3 each time. So that means my value of the common difference is going to be 3. So I can set up everything I need to know to find n. Let's use this one. 83 is going to equal my first term plus n minus 1, because we don't know how many terms there are, times d. Well, d is 3. So let's simplify this and solve for n. Move 20 to the left, that gives me 63 equals 3n minus 3. Add 3 and then divide by 3 gives us 66 equals 3n. So n equals 22. There are 22 terms. Let's try this next one. Same process. Don't be scared of the variable, or we can still do the same thing. So the first term is going to be 6a. The last term is going to be -22a. And then notice that it's -2a each time. -2a, -2a. So d is going to be -2a. So we can write it out. -22a is going to equal my first term, 6a, plus n minus 1 times d, which is -2a. We don't have to actually solve for a, we're just solving for n. So let's -6a here. That gives us negative 28a equals negative 2an plus 2a. Subtract 2a, that's going to give us negative 30a equals negative 2a times n. Divide by negative 2a. Negative 30a divided by negative 2a is 15, because the a's will cancel. Negative 30 divided by 2 is 15, so that means there are 15 terms. Okay, three numbers are consecutive terms of an arithmetic sequence, so they follow after each other. The sum of the three numbers is 45, and their product is 3,240. We need to find those three numbers. To solve a question like this, we're going to use a nice mathematical trick. If these numbers are consecutive and it's an arithmetic sequence, then they're growing by the common difference d each time. So I can let the middle term be u, then the next term is going to be u plus d, and the term before it is going to be u minus d. There are other ways to solve this problem, but this is a nice mathematical trick that you can use to solve it quickly. So the sum of these three numbers has to be 45. So u minus d plus u plus d has to equal 45. Well, notice negative d and positive d will cancel. That's why we did it this way. And you're left with 3u equals 45. Well, quickly you can see that u must be 15. So your middle term has to be 15. Now you need to find the other ones. Let me rewrite this. So this is 15 minus d, 15, and 15 plus d. So we know these three multiplied together has to equal 3,240. So that would be 15 minus d times 15 plus d. And that's going to equal 3,240. So again, this nice little trick works out because 15 minus d and 15 plus d are actually opposite signs. When you multiply them, you get the difference of squares. And so that becomes 15 squared minus d squared, and then all that is times 15. Let's divide out 15, and we get on the right hand side 216, and then on the left we have 15 squared minus d squared. 15 squared is 225, and then I can actually move 216 over, and that's all going to equal d squared. 225 minus 216 is 9, so d squared equals 9, which means d can be plus or minus 3. So our numbers can possibly be 15 minus 3, 15, and 15 plus 3, or the other way around, 15 plus 3, 15, and 15 minus 3, because it's symmetric. So this is 12, 15, 18, or 18, 15, 12. So these are the three terms that we are looking for. Okay, last question. The second term of an arithmetic sequence is 20, and the seventh term is 55. Find the first term in the common difference. So this is a question you will see a lot. The second term is 20, and the seventh term is 55. Find the first term in the common difference. So let's set up two equations. The first one's going to be 55 equals u1 plus n is 7, so 7 minus 1 times d. I don't know d. And the second one's going to be 20 equals u1 again plus 2 minus 1 times d. And I'm just using the general formula to set up these two equations. Okay, let's simplify this just a little bit. 55 equals u1 plus 60, and 20 equals u1 plus d. So now I'm actually going to subtract these two equations from each other. 55 minus 20 gives you 35. u1 minus u1 actually cancels, and then 60 minus d gives you 5d. Divide by 5 on both sides, and you see that d must be 7. So now you've got a key component, and you can now plug it back in and solve either one of these using what you know. Let's just use the second one. 20 equals u1 plus 7, because I know d must be 7. Just subtract 7 on both sides, you see your first term must be 13. Alright, that's it for this lesson. Now go and try some practice on your own.